Now there's more than one way of representing functions. We've already seen that you can write f of x equals 2x plus 1 as an equation. You can also write it as something we call a mapping, like this. But we can also represent functions with graphs in 2 dimensions, for example, and also as tables of values like this down here. So, if we look at this graph, would it be possible for us to say what the domain of this function is and what the range of this function is? Well, what we have to look at is, for the domain, we have to look at all the possible x values. So think about x starting here and going to the right. So it's all the x values over here. Now, this arrow indicates that this line is going to continue to go up in that direction. So there isn't going to be any limit to how big x can get, but it has to start here at -2. So from the graph of the domain, we can say that the x has to be bigger than or equal to -2. If you think about the y values has to start at -1 and it can go up in this direction as far as we want. So it's a similar kind of thing. We can just say that the range is going to be from that -1 upwards. So it's y is bigger than or equal to -1. For example 5, you'll see that we have data for times and distances, and here we have an axis which is for time and an axis which is for distance. And what we do is we plot the points, we go across to 10 and we go up to 25, and the point that we want is going to be round about here, 10, 25. So we're going to have a point that's going to be at 10, 25. We're going to have a point that's going to be at 20, 40. So we go across to 20 and up to 40, round about there. Then 30, 55. These are all quite approximate drawings that I'm putting on here. 40, 70 is next. So go across to 40, up to 70. And then 50, 85 will be the last one. You'll notice that makes more or less a straight line. So what I can do now is just join up those points, or plot those points and join them up with a straight line like this. Now just one more thing. We have something called a piecewise function, which is something that's defined for different parts of the domain with different equations. So if you have a value of x that's less than or equal to 1, your f of x is just equal to x. But if your x value is bigger than 1, so for example if it's 2 or 4 or 5, then you have to square the x to get your output value. So if, for example, I want to find f of 0.99, 0.99 is less than 1, so it's going to be just the same as x. So in this case here, the input is 0.99, so the output is 0.99. If we think about 1, well, 1 is less than or equal to 1, so if our input is 1, our output should also be 1. However, if we look at 1.01, you'll notice that value is bigger than 1, so we have to square that value. So we're going to have 1.01 squared, which is 1.0201. And the same thing applies to 3. 3 is also bigger than 1, so we have to square that also. And if we put -3 into that equation, well, -3 is less than or equal to 1. So our output should be just -3.